Okay, now, last week we already learned about semester learning plan, and then all the assignment that we need to work on for this semester, for this class, and then the due date and everything. And then hopefully you guys already checked SIPDA, because I already uploaded the link for the assignments, and then I already uploaded the semester learning plan. Okay, now so this will be our second meeting, and then the second meeting we will work on the introduction for the qualitative analysis, right? Because for this class there are two analyses that we will be working on. The first one will be qualitative analysis, and then the second one will be quantitative analysis. Now, so for qualitative analysis, we have two types of tests. So there are two types of tests. The first one is dry reaction, and the second one is wet reaction. So just from the term dry and wet, we kind of know what kind of reaction it will be. Okay, now for dry reaction, of course this will be for solid substance, because there are material that you won't be able to analyze it unless it is in the original phase. So you don't need to make a solution. So you just the material by itself. Okay, now the second reaction will be wet reaction. No, if it's wet, then we know we will test it in the form of solution. In this case will be for example, the material will be dissolved in water or in alcohol and so on, and then we will do some type of reaction so that we can test it. Okay, so this is two kind of tests in the qualitative analysis: dry reaction and then wet reaction. And of course, each of the tests, there will be advantages, there will be disadvantages. Now, for dry reaction, the advantages will be you can do it in short time. So you don't need, so your analysis won't take a longer time, short time. Okay. And then it will give you a knowledge, a knowledge of how you will be able to do the qualitative analysis. So this is the advantages for dry reaction. Okay. Now, do you guys finish write this down? You guys finish writing this down? Okay. How about this one? Finish? Yes?
Yes.
Okay. Why don't you guys write it down before I continue? Okay, finish? Now, so this is definition for dry reaction. So definition of dry reaction is you work on the task in a dry condition, meaning you don't need to dissolve the sample. So there will be no water in the reaction. So this is like a reaction without water, right? So this is dry reaction. And how you do dry reaction, the first one is you do it by heating. So you do it by heating. For example, you put your sample in sort of like a needle, something like that, and then you approach the sample into the Bunsen flame, and then like while you heat your sample, then you observe what kind of phenomena that are happening when you heat your sample in the Bunsen flame. Okay, now, so this is the example. So this is sort of like a needle, right? It has a long handle, and this is like a fancy Bunsen flame, right? Because you can control how your flame is. I don't think we have it in our lab, but this is the fancy style. Okay, and actually you put your sample in this hole, right? After you put it in the hole, and then you approach the sample into the Bunsen flame and let it burn, let it heat, right? And of course, since this is a test, you can observe many things. First, you can observe whether the flame will change color. Okay, the first one. The second one, you can observe whether there is a gas produced, right? By gas produced, meaning that when you do this test, you can smell. Maybe you can smell different kind of odor. Because like maybe at first like before you heat it, there is no odor in the sample, right? But when you approach the sample into the Bunsen flame, and then you start smelling a different kind of odor, and then you know that there is a reaction happening, right? So color, odor, that will be happening when you do dry reaction. Now, so things happen after heating, right? Like I mentioned, sublimation may take place. Sublimation means your dry sample will change from a solid phase into the gas phase. So this is sublimation, right? Now, also your material may melt or decompose. So melt or decompose. Now, when it melt or decompose, it will accompany by a change of color. So that's why you need to pay during the dry reaction, you need to pay attention whether your flame will be changing or not. Yeah. Now, the next one, like I said, gas may be evolved. Yeah, gas may be evolved. Now, when gas evolve, like I said, there will be a different odor. You can smell it, but you cannot smell it like close to the flame, because maybe the gas is not good for your health, but you can smell it by like this. Yeah. So it means like the gas will be coming through your nose, but it's not directly. It's not in the high concentration, but a dilute concentration, because it's far from you. Okay, so this is happening, and by looking at all of this, you may understand what are the property of the material that you are test. Okay, now there are also heating tests like this, dry test like this. You can see this is the material, right? And this is the Bunsen flame. So what you do is you don't directly put your material in the flame, right? But you blow the flame so that it will touch the material. So it's different from what we see in here, right? What we see in here, you directly approach the material into the Bunsen and burner. But for blowpipe tests, what you did is you blow the flame in here so that it can touch the material. So you don't put directly the material into the flame. Okay. Now, so what we will be learning in the blowpipe flame, right? So you can see here, the flame in this Bunsen and burner, the temperature are different. Yeah, the temperature is different. So when you want to do dry tests, you need to see, you need to understand what are the temperature for each of the region in the Bunsen and burner. Okay, now, so you can see here, we have reduction part, we have luminous cone, and then we have unburned gas, and then we have invisible flame envelope. Okay, now, so you can see the reduction flame, this is outside the flame, outside region. Okay, now if you blowing gently, so you blow like a flame, so the material will be heat, but not into a high temperature, because you just blowing gently the flame. Okay, and then you can see here, like the outside of the flame is the one that have a low temperature flame. Okay, did you guys finish write down this slide? Okay, I'm gonna wait for you guys to wrote it down. Okay. Okay, finish? Now, so next, so you can see here, the reducing flame is this part, right? The oxidizing flame is the inside part. Yeah, the inside part. So you can see here, the hottest part of the Bunsen flame is the one that are inside in here. And the color will be blue. Yeah, blue. So when you turn on your gas, yeah, your gas stove, for example, if the flame, the color is orange, meaning is there is something wrong with your gas stove. Okay, the ideal of gas stove is the color should be blue. Yeah, blue. Why? Because that will be the hottest part of the flame. Okay, so you can see here, this is the reducing flame, and then this is the oxidizing flame. Yeah. Now, so let's see here. So this is the region of the flame. So this part is what we call upper oxidizing zone, and this is upper reducing zone. And you can see here, this is the hottest portion of the flame, right? And we have here lower oxidizing zone, and then lower reducing zone. And then you can see here, this is lower temperature zone. So it doesn't mean that even though this is close to the bottom, the source of the energy, it's still, we call it lower temperature zone. So the hottest part is in this region, and usually the color will be blue. Yeah. So you can see here, the non-luminous Bunsen flame consists 3 parts. So we have an inner blue cone. This is A, B, D. So this is the blue inner blue cone, and usually this is the the hot area, right? And then we have also a luminous tip D, yeah, tip D. And then we have also A, B, C, D, and this is A, B, C, D is the outer, right? The outer of the flame. And then in this part, we call it, this is the complete combustion of gas occur. Yeah, this is where the complete combustion of gas occur. And then, so what will be the principle for the flame test here? So the principle is the lowest temperature is at the base of the flame. So you can see here, this is the lower temperature at the base. Yeah. And then how we can use Bunsen flame, Bunsen and burner, we can only use it for volatile substance. So what is the meaning by volatile substance? What is the meaning by volatile?
Senyawa yang dapat menguap.
So volatile substance means is a substance that are easy to vaporize, right? So a substance that are easy to change from liquid phase to a gas phase. So it means like we can only use flame test when we have a volatile substance. Yeah. Now, how we know that there is a reaction is whether there will be a change color in the flame. Yeah, if there is a change color in the flame, then there will be a reaction. Okay. Now, so you guys remember zone B, right? Zone B. Zone B here is the hottest. Yeah, the hottest part of the flame. Yeah. Now, zone B is the hottest part of the flame, and usually this is testing if you have a mixture substance. Yeah. So remember, if you have a mixture substance, meaning there will be a steps, right? A steps for you to test it, right? Because it's a mixture. Then you need a temperature sort of like higher. That's why if you have a mixture of substance, you need to test it on zone B, which is the hottest part of the flame. Now, do you guys finish, wrote down this one? Finish? Yes? Finish? Not yet? Okay. Why don't you, from where did you guys need to write it down? From here? Or from here? Huh? Yes?
This already, ma'am.
This is already? How about, so this one, from this?
Yes, ma'am. Yes, ma'am.
Okay, good. Can I finish this one? Not yet?
Already, ma'am.
Ready? Okay. How about this one? Finish this one?
Finish, ma'am.
Yes, ma'am.
How about this one? Not yet. Of course, not yet, right? I forgot. Did you guys finish this one? Finish writing this one?
Yes, ma'am.
Yes. This one. Oh, this one, right? Okay. Okay, finish? Okay, now. So we already learned that zone B is the hottest part, right? Hottest part of the flame. And then usually we will test a substance that are mixture. So campuran, yeah, campuran. Not only like a single substance, but a mix of a substance. Now, zone C, zone C, this is what we call a lower oxidizing C. And usually we will test borax, sodium carbonate, microcosmic salt. So these three types of chemical substance, we can use zone C. So it's good if you when you wrote down, right? You draw this one. Did you guys draw this one? And then you will know like which one is zone C. Zone C is this one, yeah, lower oxidizing zone. So we can testing borax, microcosmic salt, and then what else later? I forgot. So borax, sodium carbonate, and then microcosmic salt. Okay. And zone D, yeah, zone D. Zone D, we call it upper oxidizing zone. Yeah, upper oxidizing zone. And we will test, we will for this part, usually it has a large amount of oxygen. Okay, hold a second, okay? My mother called me, so hold a second. Yeah, I'm sorry. Let's continue. Okay. Now, so for zone D here, right? In zone D, we have excess amount of oxygen, but if we compare it with zone C, the temperature in zone D is not as hot. It's not as hot as C. Yeah. So what can we do in zone D? What we can do is we can do oxidizing process, but when we don't need a high temperature. Yeah. So whenever we need to oxidize a material, right? But in case the material is maybe like temperature sensitive, then we can use zone D. Finish this, finish writing this. Yeah. Now, next we have zone E. Yeah. No, zone E here, let's see, I put like a small picture here. Zone E is this one, right? Now, we call reducing, lower reducing, yeah? We call zone E, we call it, hold a second, upper, yeah? Upper reducing zone, yeah? Upper reducing zone. And in this region, it has a lot of carbon, yeah, a lot of carbon. Then it means this region we can use it to reduce oxide into metal. So we have, if we have, for example, a material that has a crust, yeah, a crust, karat, yeah, karat, we can heat it in this region to remove the crust. So that's why this is, it said useful for reducing oxide incrustation to the metal. Okay, so you can see like a different region in the Bunsen flame, it has different function. The part that are rich in oxygen, you can use it to oxidize the material. But you can see here the part that are have carbon, You can use it to reduce your oxide metal into a metal, or meaning you remove the crust in the metal. Okay, finish this one, writing this one. Now, zone F. Zone F, you can see here, I put like a small picture in here, F, yeah. F is lower oxidizing zone, yeah. You can see the blue mantle is inside here, right? The blue mantle, right? This is the blue mantle. So F is outside, outside in the edge of the mantle. Now, you can see, since this is outside, your oxygen is mixed with air. So if the oxygen is mixing with air, it means the reducing ability of this F zone will be less, because the oxygen is not pure. It's already mixed with the regular air. Yeah. Now, what can we testing in the F? What we can test is also borax or other material that are similar to borax. Okay. So until this part, do you guys have any question? Do you guys have any question? Finish this one? Not yet? Okay. Finish, right? Okay. Now, next. So you can see here, we have several flame tests for transition material. Yeah. So you can see if we have strontium, lithium, the color of the flame will be crimson red. So crimson red is like a blood color, right? And then if we have calcium, the color will be brick, red brick, berarti merah bata gitu ya. Now, if we have barium, the color will be apple green. So if you go to supermarket, right, there are many types of apple. There are also green apple, right? So if you flame test barium, the color will be green, apple green. Okay. Now, if we have potassium, yeah, potassium, the color will be violet, ungu, lilac. Yeah. Now, how about copper? Copper will be blue-green, so different green. Barium is apple green. Copper is blue-green. Okay. Now, how about sodium? Sodium will be golden yellow. Nickel will be brown. So this is the flame test for transition metal. Now, I don't know. Did you guys get the practicum module yet? Did you guys already receive it? Not yet?
Not yet, ma'am.
Yet. I don't know, maybe if there is a experiment that related with the flame test for this transition material, it will be exciting, of course, right? Then like when you do the experiment, one of your friend can take a picture, right? And then you can put it in your report, so so it will be like nice, and then you can suddenly understand if you compare to the lecture today. Okay, because like for lecture, I can just told you guys that if you flame test strontium and lithium, you will get crimson red. But I don't think you can imagine it in your head, right? But if you do lab, right, you can directly see. You can directly see, and oh yeah, so when we heat all of this material, then the different color will be appear in the flame. Okay, now, so next we can do also qualitative analysis of salt. Yeah, salt. Now, so for example, if we have salt, yeah, definition of salt, meaning we have cation and anion. Yeah, now cation is base, basa. Anion is acid. So we can also call cation as a basic radicals, yeah, radical basa. Anion, we can call it also acid radicals, meaning radical asam. Yeah. I'm gonna give you guys a chance to wrote it down first. Finish this?
Finish, ma'am.
Yes, okay. Now, so this is the procedure for doing salt analysis. So there are four types of analysis. The first one, you can check observe the physical appearance. So you can see the color, you see the smell, you can see the density, right? You can see the deliquescence. And then the second test, you can do the dry heating test. In the dry heating test, you can see whether there is a gas evolve, if there is a sublimation, if there is a decrepitation, if there is a different kind of flame, if there is a residue, right? And there are also other dry tests, like you can use charcoal cavity test, borax bead test, microcosmic salt bead test, and then flame test. Okay, now, so these three is dry test, right? This is for salt analysis. Now, the last one is, we call it wet test. And then wet test here, you can use acid radical or basic radicals. So this is to confirm, yeah. So you can sort of like get an idea what salt you have from these three tests, right? But then to confirm it, you need to do a wet test. So there you need to do the combination also for this salt test. Finish this? Not yet? Okay, finish? Okay, now next. So physical appearance, right? Because remember, there are four types, right? The first one is physical appearance, okay? Now, in physical appearance, right, you can have, for example, color. Now, color, usually you can see in the transition metal. Why you can see in the transition metal? Because for transition metal, you have a D, right? Remember SPDF, right? In transition metal, usually the outer cell is D or even F, yeah, SPDF. Remember I think this semester you guys also will learn about quantum chemistry, right? In quantum chemistry, you will learn about orbital SPDF, right? And if there is a transition, electronic transition, right? If the there is electronic moving from this orbital, then it will emit color. Okay, so that's the reason when transition metal have color. Now, observation, let's see observation. If you have copper 2+, nickel 2+, you have blue or bluish green. Now, if you have nickel, nickel 2+ is green. If you have iron 2+, the color will be reddish brown. If you have iron 3, so you need to differentiate. 2+, iron 2+, you have reddish brown, but iron 3+, you have pink violet. So it's a beautiful color, yeah. So if you have cobalt 2+, you have light pink, light pink. Okay. Now Mn2+ in here, we have white color. So we have white color. So you can see here like based from the appearance of the material, right, of the metal, then you can decide what are the type of metal that you have. Okay. Now, smell. Smell is you can smell the odor, right? So if you smell like a rotten egg, telur busuk, yeah, then meaning you have sulfur, sulfur 2-, yeah. If you smell like vinegar, then you have CH3COO negative. So if you have like if you go to a restroom, right? If you smell like ammonical, right? Ammonia, then you have NH4+, ammonia. So based on this appearance, the color, the smell, right? The smell is, for example, you go to the book, right? If you want to go to the book and then you have like a hot spring, right? You can smell like a pungent rotten egg smell, right? And then if you use a certain cloth, like the cloth will smell like that like for ages, right? Even though you wash it, it won't disappear, right? So it means like the debu has a sulfur in that, have a composition of sulfur. Okay, now density. So dry heating also have density. Density is whether you have a heavy or light powder. Yeah. So for example, plumbum 2 plus, barium 2 plus. Yeah. It can be heavy or light. It will depend on the type of material. Okay. Did you finish wrote down this one? Not yet? Okay. I'm going to give you a chance to wrote it down. Halo, Fred. Iya, kenapa, Fred? Okay, sorry. I have some problem, so that's why I need to stop it and then let's continue. Okay. Okay. My computer battery is almost gone, so let me check it first. Okay. Yeah. Now, so did you guys finish write down this one?
Finish, ma'am.
Yeah, okay. Now, next, deliquescence. Yeah, deliquescence. So what is the meaning by deliquescence? So deliquescence here is meaning like when you have a substance, right? The substance can absorb moisture. So you leave it there, right? The substance is usually like a solid, right? And then it has the ability to absorb moisture from the atmosphere. And then until it changes into a solution. So this is what it means by deliquescence, right? Now, for this cation, yeah, for this cation, they have like a colorless cation also. So for example, magnesium 2 plus, aluminum 3 plus, zinc 2 plus, three of them are colorless, yeah, colorless cation. And then when we have colored, yeah, colored, hold a second. Colored cation is copper 2 plus and iron plus. Yeah, copper 2 plus and iron plus. And hygroscopic. So definition for hygroscopic is when you have a material that can absorb a water and it will form a water crystallization. Yeah. So this is the meaning by hygroscopic. So you can see here for qualitative analysis, right? You don't have you can see, for example, color, whether it has color or it is a colorless, right? And then you can also have a water crystallization, like a hygroscopic, yeah, when it's absorb water and it will change into a solution, yeah. Now, sublimate. Sublimate meaning is you have a solid and then it can change into a gas. Yeah, it can change into a gas. So sublimation basically is a decomposition of a solid substance, right? A decomposition of solid substance. So you can test it. So for example, if you have ammonium chloride, mercury 1, mercury 2, yeah, arsenate 3, and then antimony 3 and selenium 4, all of these have a white color. And if you have a sulfur in the solid form, so free sulfur means sulfur by itself is not a cation or anion. So sulfur, pure sulfur, the color will be yellow. Yeah, the color will be yellow. And then if you have arsenate 3, sulfur 3, this is also yellow. And then also mercury. Yeah. So this is basically how you test the solid part. Okay. Okay. Now, next is decrypitation. Decrypitation is you can do a decomposition of the material, right? And usually you can hear a sound, a crackling. So for example, you have a material and then you heat it, right? And when you heat it, it will produce a sound. Okay. How you can do this testing? You can do this testing if you have a water, a salt that doesn't have a water. So it's a pure salt. Because sometimes you have a salt, but it contains a water crystal inside. So if you have a water crystal, like for example, hygroscopic material, right? It contains water crystallization. So when you heat it, it will have it won't have a crackling sound. But when you have a salt that doesn't have a water, right, like halide or halide of alkali metal, then you will have a crackling sound when you heat it. Okay. Now, swelling. Swelling is, for example, you have, for example, phosphate anion, and then borax anion. Then you can test it with swelling. Okay, swelling. Okay. Now, residue. So if you have zinc oxide, yeah, zinc oxide, when you heat it, the color will be yellow. But when it's cold, when you don't heat it, the color will be white. And then for lead oxide, also have different color. When you heat it, the color will be brown. And then when you when the temperature is cold, so meaning like after you finish, after you let it cool down, the color will be yellow. Yeah. And for barium, strontium, calcium, magnesium, all of this will have a white residue when you heat it. Yeah, it will have a white residue. Now, so for example, copper sulfate, right? You heat it, right? Copper or copper sulfate in the cold temperature, like in the cooling states, the color will be the color is blue. Yeah, the color is blue. But when you heat it, the color will be white. So there is a changing color for copper sulfate when you heat it. So from blue to white. Now, there are also like many different salt that when you heat it, it will become brown or black. Like for example, cobalt, iron 3+, iron 2+, chrome 3+, copper 2+, nickel 2+, and Mn 2+. So all of these are color salt that when you heat it, it will change into brown or black color. Now, next, we have what we call borax bead test. Yeah, borax bead test here. What we do is, this is borax, yeah, Na2, Na2, natrium, sodium B4O7, 10 water. So this has a water crystal, yeah. Borax basically have a water crystal. So this is what we call a salt of boric acid. So what you do is you have a loop like this that are made of platinum, yeah, made of a platinum. So you heat it until have a flame in this platinum, and then you dip it into the powder. So that's how you do the test. So first you have a platinum wire that you make a loop like this, right? And then you heat it in the Bunsen flame until this changing color to red hot, right? And then you dip it into a powder, the powder that you want to test, yeah? And what happened is when you heat it, see, remember this one has a water, right? 10 H2O. Then after you heat it, the water crystallization is disappearing, right? Disappearing. And what happened is in the loop, you have a glass, yeah, a glass, because borax is basically is like a glass, like a bead. So the thin the water is disappearing, and it form like a glass in this loop. Yeah. Any question until this part? Any question? No? Okay. Now, so this is the reaction, right? You have this one contain 10 water, right? You heat it, then it left only sodium sodium B4O7, and then you heat it again, and it appear like this is the chemical, and this chemical is, it doesn't have any color, and then transparent, and then it form a bead. Yeah, it form a bead. Okay, did you guys finish write this one? This one? This one? Finish writing this one?
Not yet, ma'am.
Okay, why don't you write it down first? Finish? Okay. How about this one? Not yet? Okay. Okay, finish this one. Finish. Okay, now how about this one? Did you guys finish it? Not yet. Okay. Finish. Okay, now heat and observe. So for example, the bead is moistened. Remember, right? So you have a platinum wire, right? You heat it, right, until it has like a flame, and then you dip it to the borax, right? The borax, it will produce a glass-like material, right? And then you heat it again, the bead that are already produced, right? The glass-like material, you heat it in the lower reducing flame, yeah, in the lower reducing flame, and then you allow it to cool, right? And then you can see a different color, yeah, you can see a different color. And then if you put the bit like glass, you already dip it into like the salt that you want to analyze, right? And then you heat it in the oxidizing flame, and then you let it cool. You can observe color again. So that's how you do a borax bit analysis. Yeah, that's how you do a borax lead analysis. Okay. Any question until here?
Ma'am, I want to ask,
Yeah.
usually the color produce what color, ma'am?
Or depend on the salt that you're testing. Depend on the salt. Because remember, this one is only the preparation step, right? After you form a transparent glass-like bead, you dip this material into the salt that you want to analyze, right? After you dip it into the salt that you want to analyze, then you heat it again. So that's why this bead is heated in the lower reducing flame. So meaning that you can test it both in the reducing flame or oxidizing flame. So then the salt that you analyze will produce color. So if you ask what kind of color that will appear, then it will depend on the material, on the salt that you want to analyze. Yeah. Okay. Is it clear, Rizky?
Yes, ma'am. Thank you, ma'am.
Okay. Any more question? Any more question? No? Okay. Now, the color of beads, yeah? So if you have a color beads, remember, then it means you have a transition metal borax. So if you have a salt that contain, for example, nickel borax, copper borax, then you have a color beads. Remember why we have a color for transition metal? Because of what? Because of what? Why we
Because
have
of the
color?
orbital SDFX movement.
If we have a DD electronic transition, yeah, or FF electronic transition, okay. So all of the reason that we have a transition metal in color, yeah. Okay, so this are the example, the reaction in borax test, yeah. So if you have copper oxide, then you have like blue color, yeah. If you have this is copper 2, yeah, copper 2 plus. Now if you have copper plus, yeah, copper 1, yeah, copper 1, you have a red color bead in reducing flame. So even though you have the same copper, right, but you have a different oxidation state, the bead will give you a different color. So copper 2 give you blue color, copper 1 give you red color. Okay? So that's how this and analysis are interesting, because you're not only able to differentiate different metal, right? But you can differentiate different oxidation state of the same metal. Yeah. Okay. And is it clear for you guys for this part? Is it clear? How come 21 student here rarely want to talk? Like if I ask you question, you just you don't say it with your voice. Why is it like that? Huh? So if I ask you, do you understand? It's easy. You just said yes, miss, or yes, miss, or you can say no, I don't understand, and then I will ask you guys which part you guys don't understand, right? If I'm the one who only talk, it's not interesting for me, right? You guys should also like interact with me so that this class will be nice. Okay. Okay. Did you guys finish write down this one?
Not yet, ma'am.
Not yet. Okay. You can write it down. Finish? Not yet. Okay, Ines? Yeah.
This, ma'am.
Okay. No, so we have a table here, right? This is a different ions, the color of the flame in different ions. So for example, copper, if it's hot, it has a green. When it's cold, it has a blue. But this is in oxidizing flame. So you can see here, even in different position of the flame, it will produce different color. Yeah. So in oxidation flame, the copper will produce green. But in reducing flame, it produce colorless. Yeah. But when it's cooling down, after it's cooling down, we can see a blue color for oxidizing flame. And then for reducing flame, it will have a brown red. Yeah. And also for iron, for example, iron has a brown yellow in oxidizing flame, bottle green in reducing flame. Yeah. So you can see here, this is like the nice part for the test using flame, right? Even different region in the flame will give you different color, then will give you different information. Yeah. Okay. Until this part, do you guys have any question?
Ma'am, I want to ask again. Is it possible if we don't get the same color as the table, ma'am?
You don't get the same color from the table.
Table. Yes,
So if you don't get the same color from the table, meaning your sample is impure. So maybe you have like a mix of two different kind of metal. Then you won't get the same color from the table here. Okay. So the color here, right? The color that we have in here, all of this is for pure copper, pure iron, pure chromium, pure cobalt, manganese, and nickel. So for example, if your sample is already, so for example, you know your sample is copper, right? But then for some reason, it's polluted with manganese. So you have like a little bit manganese like on your copper without you knowing. You don't know it, right? And then you testing the copper, you won't get green color there. Why? Because your sample is impure. Okay, so it's possible you don't get this color if your sample is impure. So that's why we call this class is analysis, right? Qualitative and quantitative analysis, because we want to analyze, right, whether our sample is pure or not. Okay. Now, I think let's stop this class. Yeah, let's stop this class. We already study like we still have 15 minutes, but I guess we just stop it and then we continue next week. Okay. Before I end the meeting, do you guys have any question? Do you guys have any question? No? Okay. And then I will upload this, I will put the link for this video in SIPDA. Okay, so if you have like a time, you can watch it, and then so that maybe there are some like note that you are missing, you can check it from the video. Okay. Okay, thank you. See you next week. Bye.